today we have a relatively short finish. It's one of the things I like about 17. The skills, the mathematical skill set is very small. Basically, we're going to do something similar to what we did with the normal distribution, where we add and subtract this number, and instead of doing it multiple times, you're just going to do it once. What we're going to be looking at is polling and margin of error. I think this is a good finish because it's an important intersection of mathematics and the world. And the margin of error, I think, is a nuance that a lot of people don't appreciate about polling. To kind of lay the groundwork for why I think this is important, I read a book a couple years ago called The New Jim Crow, which is by Michelle Alexander, about the era of mass incarceration, which if you're more into movies than books, 13th by Ava DuVernay is a very good kind of explanation of the era of mass incarceration, which basically pivoted from this end of the civil rights era, which was a victory in a lot of ways, and we passed laws and said, okay, you can't discriminate against Black people. But they really shifted towards law and order, crime and punishment, and finding ways to lock up more and more people. So that now we have, I don't know, somewhere over 2 million people locked up in this country. And we have like 25% of the world's prison population is in the US, which is pretty incredible. So one of the things that was very powerful to me that connects with polling was this part of the book that she was talking about drug use. One of the enduring stereotypes that's really a racist myth is that Black people are more, criminals and more likely to be criminals and be doing bad things. And drugs in particular are one of the ways that first Reagan and then Bush and then Clinton all kind of criminalized people, and especially Black people. And so it was a very powerful part of the book for me for her to look at the sociological research around drug use. And the sociological research around drug use indicates that Black people, white people, rich people, poor people use drugs at the same rates. About 8% of the population uses drugs. And that was very helpful to me to kind of really get into my head how this had been used unfairly to target a specific population. So polling, I know when you hear the word polling, you probably think of politics and the horse race, who's winning, who's going to win this election. But polling is bigger than that. It's really about surveying. It's about asking a group of people what they think or what they believe and trying to determine something about a group. And the amazing thing about mathematics is that if you randomly select a group of people, you don't need a whole lot, probably around 1,000 people, to get a reasonable estimate of the larger population. So this is a big idea, that you can randomly select 1,000 people, get a sense of the beliefs, behaviors, practices of 320 million people. I mean, it's just a wild idea. But to try to explain it in terms that might make more sense or might help you accept that's true, because actually you've got to take quite a bit of statistics to get to that point and that conclusion. But if you think about a big pot of soup, I always like to use this analogy. I don't know if you've ever made a big pot of soup, but if you make a big pot of soup and you mix it up and then you take a spoonful off the top, it's a reasonable expectation that that spoonful is going to represent the whole soup. You don't need to eat the whole pot of soup to know what it tastes like. So that's the same thing that's happening. It's just harder to imagine because we think of people as individuals, and it's kind of hard to imagine taking a pot of 320 million people and mixing them up and then randomly selecting 1,000. And it is challenging to do that. There's been a lot of stories about people who did polls badly, and didn't get a really good sense of the entire population because they did a bad job at randomly selecting people. And you can easily imagine how that could happen. If I want to, say, get a sense of how people feel about a certain policy, and I start randomly dialing phone numbers, I may be randomly entering numbers into my phone, but there's a problem on the other end, which is that who's going to answer the phone for a random caller? Do you answer the phone when you get a random phone call? Well, I don't. And I suspect a lot of people don't, especially in the last couple of years. We've seen a huge increase of, you know, what do they call it? Spam calling, where they have programs that will just randomly dial numbers and they'll try to get through to people. Hey, I heard you signed up for this thing and I wanted to tell you about the opportunity that you're going to shut up. But there's a way around that. And that's what the people who do this work have to figure out, is how to get a good, true, random, representative sample of the population in order to get that. So I find this topic very interesting, but I don't want to bore you. I want to start with the book. And let me just, because there's a couple of questions that are kind of introduce it, and then I'm going to take it to the web and show you some examples of how this is, you actually could see this if you're reading things online. Sorry, let me get my textbook open. Guys, if you have any questions about anything I've said so far, don't hesitate to jump in. Okay. So this is on page 225. Now, there's a little exercise at the front end to think about fair or biased polling. I would love to build this into a real project where you guys write some of your own questions and go and try to get a representative sample. And that is, again, something to think about. But if you're reading polls that have already been done, you're not the one who's doing it, so you don't have to worry about you know, whether it was fair or biased. It's really there, you have to develop trust in who you're listening to and whether they know what they're doing or not. And there's various ways that you could try to determine that. So here's what we're going to do with margin of error. We're going to look at a study, and then we're going to take the margin of error and we're going to create something called a confidence interval. And this is where the really big idea around polling is that you should know that when a poll, a top line result is published, that is the result of the sample. And in order to properly talk about the conclusions that we can reach from that, we need to use some special language and create this confidence interval. Okay, so this is already pretty old, 7 years old, but you can see that in this time there had been increasing interest and use of cell phones to get on the internet. Now I imagine that it's much higher. We could look up the number if we're interested. But the top line they're giving you is 2/3 of cell phone owners now use their phone to go online. Okay, so I'm going to write that conclusion down because that's kind of the top line conclusion. 63% of cell phone owners in 2013 use their phones to go online. Okay. Now that's belongs in an article, but what we want to do in this last section is just build some nuance to make a more comprehensive statement of what's actually happening here. if you look at the bottom of this graph, it tells you something about the margin of error. Can you see where it says that? What is the margin of error in this situation?
Is it 2.4?
Exactly. Margin of error based on cell phone owners is 2.4 percentage points. And so the first thing we want to be able to do is identify the confidence interval. And that's just 63% plus or minus 2.4%. So your job, and this is really the only math that's going to happen in this section, is just adding and subtracting 2.4%. What we really mean is that we think the answer is somewhere between 60.6% and 65.4%. Okay, you understand where those numbers came from?
Absolutely not.
Okay, this says plus or minus, right? So one thing I did was I took 63% and I added 2.4%. What's that make?
Is that how you got the 6.5?
65.
That's where I got 65.4. Now, on the other hand, I could do 63% minus 2.4%. And what does that give me?
You finished?
The 60.6.
The 60.6. That's it. That's all the math you got to do for this section. Add and subtract.
Is that it? Because the way the question was, I was doing the homework. I was so confused. I was like, what in the world?
Well, there's conceptual things that are tied in here. So you have to be able to identify, you know, what's being said. And there's a lot of percentages flying around. And so we'll take some practice to kind of get it all straightened out. But yes, this really is the only math you have to do for this section. Okay. So the confidence interval basically is the only math we have to do. And then what we would want to do is we want to translate this into a more nuanced sentence. This is the top line that you would see in an article, but we would really want to say something more like this if we were being more scientific about it. We have 95% confidence that between 60.6% and 65.4% of cell phone owners in 2013 used their phones to go online. So let's think about what's the same and what's different. So this was my original sentence. I'm still talking about cell phone owners. In fact, the whole end of the sentence, I really just said the exact same thing, right? This part got tacked onto the end of that part. So it's really the front part, which is quite different. And there's a couple of things that snuck in here. First of all, 95% confidence, again, is a gimme. You're not asked to derive that. You're never going to use a different number. You know, there are different numbers in statistics because different people who are doing research want to have different confidence levels. 95% confidence means your confidence is pretty high. This is related to probability because if I was 100% confident, that means I'm absolutely certain. So what I'm saying when I say 95% confidence is I'm really sure, but I'm allowing that it's possible that I'm wrong. And that's important. It's humility. It's a reality of this whole technique of sampling. That if I go out and I randomly select a group of people, it's possible that for some weird reason, my process is flawed and I did not get a representative group, and therefore my conclusion is not valid. What was somebody just telling me about a poll recently that I felt like, I don't know if I believe that top line number. No, anyways, I don't remember. Maybe I'll remember in a couple minutes. Then the second thing I did was I instead of just saying 63%, I put in the confidence interval, right? I put in the 60.6 and the 65.4. And again, that illustrates that I understand that there's a margin of error. And so I'm showing you the margin of error so I can explain how confident I am, you know, what the range is, somewhere in between 60 and 65%, more or less. But again, the last part is really the same, of cell phone owners. Okay. So let's just do another one. I'm going to make up top line, and then I'm going to tell you what the margin of error is. And then from that, I want you to restate the sentence using the confidence interval. Okay, let's try it. So your job is to build the confidence interval and then try to restate that sentence. And you're welcome to use the last one as a template. We can use part of the top line sentence, but we need to really expand on that 76% to say it in a more nuanced way. Okay, let's see if we agree on the confidence interval. Starting from 76%, we need to add and subtract 3.2%. So what'd you come up with?
So on the plus side, you would just have 79.2%, right?
Right?
And
You guys
then
under-
somebody else subtract it because I'm driving.
Driving and doing math, that's dangerous.
I'm not a good driver anyway. It's cool.
Oh, geez.
That's even worse.
You guys understand where the 79.2% came from?
Yes.
So what's the other side?
$72.8.
That sounds pretty good. Percent. Okay, so that's my confidence interval, somewhere between this and this. If my survey revealed that 76% of people in America think marijuana should be decriminalized, what I really mean is that I think the answer is somewhere between 72.8 and 79.2% of Americans think that, right? Because this was actually based on a sample of people, not on asking everybody what they thought. But the point is that if we do it properly, we can trust that that number is a good prediction of the truth. All right, so let's try to make the sentence. The first part is a gimme. It should always be the same.
So it would just be 72.8%, somewhere between 72.8% and 79.2% of people in America think marijuana should be decriminalized.
Good. The only thing that's missing is the gimme in the front. We have 95% confidence that. That's a gimme. That's always going to be in this front of your sentence here. And then we go to the confidence interval between 72.8% and 79.2% of people in America. And in fact, I'm just going to finish with this end of the sentence here because that hasn't changed. So you see how we're constructing this sentence. We're using part of the top line, a lot of it actually, and we're just kind of fleshing out that 76% by saying, actually, it's more nuanced than just, we know it's 76%. We have 95% confidence, which is a fancy way using probability of saying we're pretty sure. And then between 72.8 and 79.2, those are specific numbers which come from the top line number and the margin of error. Okay. Any questions about that? Let's do it again. But instead of me making up numbers, let's use some real numbers. Okay. I like the Pew Research Center. They're a very reputable organization that goes out and they try to find out what people think about things. So this is a pretty recent release. It's only a month old. And I was just, that other page I had up was an exploration of how they do the research. And basically, they went out and instead of trying to call people randomly, they went out over the last couple of years and they invited people to join their panel, and then they asked the panel. It's important that they do this because then they can go back and they can look at the makeup of the panel and they can try to make sure that it's representative of America. They have some urban people, they have some rural people, they got white folks, they got black folks, they got Hispanic people, they got some heterosexual people, they have homosexual people, they have transgender. I mean, they just have a mix of people and it's representative of America. And that's an important thing that makes this believable. Okay, if I conducted this survey, it would not be very good because I would just be basing it on the people that I know and walking up to random people and trying to get them to answer questions. All right, so here's the some top lines. We can practice doing this. But what we need, okay, and they've kind of broken this down by party, but and then have the all adults lumped together here. What we need is the margin of error, because if you look at this discussion, they do not give you the margin of error up front. So let's see if, I'm going to go to the end of the report and see if they tell us something about margin of error. Oh, here we go. 95% level of confidence. So for the total sample, it's 1.6 percentage points. Okay, so go ahead and write down 1.6 percentage points. I'm going to get that number over here in Excel in a second. So at the end of the report, they tell you, and they've actually got different margins of error for the different groups, and it's based, there's a mathematical way to go from the sample size to the percentage margin of error, but we don't ask you to do that anymore. It's not really worth your time. So let's take this top line here from the very front page. And this is a little complicated, so we're going to have to try to work to construct the top line out of the various parts here. So this is the percent of people saying each factor contributed a great deal. So this is the factor that we're talking about, and 70% of all adults say this contributed a great deal to the demonstrations. Okay, so I'm going to try to put that in a sentence. %70 of Americans believe that anger over the death of George Floyd after his arrest contributed. Let me get this into a wrap text box. A great deal to the protests afterwards. Okay, so this is the top line. And what do we need in order to do the confidence interval?
So 1.5?
Now, I think it was 1.6.
Oh, okay. I'm sorry.
So the margin of error is 1.6. So go ahead and construct the confidence interval and then try to construct the nuanced sentence. Remember that the end of this sentence can be recycled and used again. We're just replacing 70% with something that's a little more nuanced to express that we're pretty sure that we're right, but there's a couple of ways that we can communicate that we're not totally 100% certain. I'll give you a minute or two for that.
Okay, and I got 68.4 and 71.6.
Nice, Leah. 68.4% to 71.6%. So that's really the first thing to do. That's the only math that you have to do here. And
Okay.
3 parts, boom, 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 to make this sentence. Part 1 is a gimme.
So we have 70% confidence that,
Nope.
no, okay.
I like the phrase, that is what we need to say. We are blah % confident. That is the first part of the sentence. but this is a gimme. It doesn't depend on anything else.
Is it 68.4?
Nope. Nope. And it was here in the report at the end. That's our confidence level. It's a statistical measure. You don't know where it came from. You're just taking it on and running with it.
Okay, so to be the 95%.
We are 95% confident. That's always going to be the first part of your sentence. Part two, now we bring in the confidence interval. That
70%.
Nope, we're not using 70% because we want to show that we understand there's actually a margin of error attached.
68.4 through
68.4% to
71.6%.
71.6.
exactly of, and now we can just jump into everything in red there.
Okay.
Okay. So in a way, if you have a top line, this is really the only part of the sentence that's you got to figure out. The rest of it is kind of constructed for you. You have to remember to say that, and you're using the top line to say the same thing. Okay. All right, let's do another one. Okay. So here's a top line, and they're talking about Black, Hispanic, and Asian adults. I suspect, and this is just this part over here. This is 9 or 10%. They're generalizing this to be about 1 in 10, which is 10%. So let's just take the top line. Now, that's a little difficult actually because of the margin of error. Let's do it. Let's do it for the white folks. Okay. So 5% say they have attended a protest. Okay. So let's write the top line. Okay, so here's your top line. Now, remember, we got to go get our margin of error. And for white Americans, it's a little different because it's a subgroup. So this is 1.8 percentage points. So the margin of error, 1.8 percentage points. So go ahead and create the confidence interval. And then try to create the sentence. Remember, there's 3 parts. Part 2 is really the only part that's got to be constructed separately. Okay, go ahead, Leah. I didn't hear anybody say they need more time. So the confidence interval is,
I got 3.2 and 6.8.
sounds good. Okay. Anybody want to jump in and build a sentence?
So we're 95% confident. between 3.2% and 6.8% of white Americans say they've attended a protest.
And then I can just steal this last part. Okay. So we're bringing nuance into what we're saying. I think bringing nuance is important because in the era of alternate facts, fake news, I think it's important to acknowledge where nuance exists, right? We don't know for sure what the number is. These are people who say they attended a rally, but we're going to take their word for it. But it's still, just somewhere between 3.2 and 6.8%. We're 95% confident of that.
Okay,
So-
so with
Yep.
just with building the census, so we're always, well, I don't want to say always, but it's going to be 90. We're trying to get the 95% confident.
Yep, you are constructing that sentence, and it's going to say 95% confident.
Okay.
If you went and you got so excited about statistics that you became a statistician and a pollster, which you absolutely could do because it's a very important field and they need lots of people, then you would understand that you could have different numbers in the front there. But for our purposes, we're not going there.
Okay.
Let's see. What are some things to talk about here at the end? This question here is the best representation of what test questions usually look like. So if you want to circle top of page 229, question 1, there's a couple things we haven't addressed so far. We've been working on C and D, basically, creating the confidence interval and creating the sentence. Although D is a little bit of a variation from what's typically asked. They would ask you to create that sentence. But let's talk a little bit about population and sample, just so we're clear on those concepts as regards to what we're going to be asked to do. When I say population, I mean, who am I trying to represent through my survey? And you don't want to write a really long sentence here. You just want to have a few key words that explain who you're talking about. Because if I say I did a survey and I want to know who's proud to be an American, there's, first of all, it may seem obvious to you who I'm talking about, but we should be clear about it. Am I talking about everybody in the world? Well, probably not, because they're not Americans. Am I talking about only people in Indiana? Am I talking about people who are older than 80? Am I talking about 5-year-olds? So what can you tell, just trying to be specific, who am I talking about? What is the population represented?
Can it be the total population?
I'm not looking for a number. I'm looking for words that describe who I'm talking about.
It says adults
America.
aged 18 and older living
Good.
in the
So-
United States.
Right. I mean, Americans is shorthand, and I would just argue that you need to push yourself a little further, because Americans, I can bring some specificity to what I mean by Americans, right? First of all, age matters. Are we talking about kids? No, it says adults aged 18 and older. So American adults would be better than just saying Americans. But American is a stand-in, right? I mean, there is a big fight right now going on in this country about what it means to be American, including whether people who live here but don't have the documents to live here should be considered part of this country or not, right? And so that is addressed in this description by not saying people who are citizens, but by saying people who are living here, right? It's a random sample of adults who live in the US. That's a better and more clear description of the population we're talking about than just saying Americans. You guys get what I'm saying?
Yes.
You don't have to write a book about it, but you want to try to use some words to be clear about who the population is that you're talking about. All right, now, second part, the sample.
So
How-
what,
Yeah, go ahead.
so it wouldn't be so we couldn't use that number 1527.
No, you wouldn't use that number because the population represents the whole group and the sample represents the smaller group that I actually talked to. So that's actually the answer to the second question. How big is the sample? 1,527. That's the size of the group that I actually interviewed. What's the population? I would say adults living in the US and District of Columbia. Okay, let me just give you another example of where that makes a difference. So we're on the cusp of another presidential election. Already people are polling and trying to get a sense of what's going to happen in November. And let's see, presidential poll national. And I'm going to click on this most recent poll. And that brings us to general election polls. So in this data set, you can see there's a lot of people who have been polling with lots of different results. You can see that a margin of error is provided. And let's just take the case of the Rasmussen Reports poll. If they got a result which was 47% for Biden, 45% for Trump, with a 2% margin of error, let's think about what that means. Now, we're not our own top line here because it's not written out in words for us. And as we think about writing the top line, there's a little detail in this report that we need to draw our attention to. So I'm going to start with Biden. It was 47% of are going to vote for Joe Biden. Okay. So my question is, and this is really what population is all about, what words will we put in here? In other words, what's the population? So let's just start with common sense. What kinds of words would we use to describe the population that we would probably be talking about if we're doing some kind of presidential poll?
Votes.
Say it again.
Is it votes?
Well, no, we're talking about people. People cast votes. So it is, in the end, about votes, but we're trying to describe the group of people we're talking about. Are we talking about all humans on the planet?
It would be Americans of voting age, so over 18.
Okay, so we could start with Americans over 18, right? And again, I'm trying to focus you on two aspects, geography and age. When we're talking about people, and it's not, we can do surveys of other things than people. That may sound weird. I mean, we obviously, if we wanted to do a survey of dogs, we wouldn't ask them questions, but we could try to take a random sample of dogs and see which dogs, you know, like to chase tennis balls or something like that. It's a much less consequential survey, but we can still survey things that aren't about people. but I'm just betting that you're going to get a question about people, not about dogs. Okay, so Americans over 18 deals with geography and age, because we're saying, and again, we're being a little vague about what we mean by Americans, but we're saying they need to be over 18 because we know that if you're not over 18, who cares how you're going to vote, right? So we're not going to ask you. Now, that's not actually technically correct, because they told you here in the sample something important that you wouldn't know because you don't look at Real Clear Politics a lot. But next to the 2,500, which is the sample size, there's a LV. Now, LV means likely voter. So a better description of the population is not just Americans, but likely voters. And then we can probably get rid of the over 18, because obviously if you're going to vote, then you have to be over 18. So what is a likely voter? Well, a likely voter is in some ways a self-identified characteristic. Like, you can't just look at somebody on the street and say, ooh, I think they're a likely voter. You have to ask them if they're likely to vote. Or you have to ask them questions about their past voting history to try to ascertain whether they are likely to vote. Now, I don't know what Rasmussen does or how they got their 2,500 people, so I can't speak to their methodology, but I just wanted to kind of illustrate why thinking about population is important, okay? So I'm gonna fill this in with likely voters. This is our top line. Do you remember what the margin of error was?
Would it be plus or minus 2?
Right, because you see the MOE column, that stands for margin of error. So that's 2 percentage points. Okay, so the margin of error is 2%. Go ahead and try to do what we did before, where you construct the sentence, you construct the confidence interval.
I have a question.
Yeah.
So that'd be 45% to 49%.
Okay, so somewhere between 45 and 49%, that's good.
Still frozen.
And now we just need to make our sentence.
Okay. We have what, 95% confidence that 45 to 49% I guess voters. I can't see the top.
Right, and then we just finish with our top line. Now, why is it significant in this case? Because Trump's numbers were, let's go back to the poll, 45%, but that's also plus or minus 2, right? And so really we would say, as we translate in nuance the numbers for Trump, we would get 43 to 47%. And you can see that there's overlap there, right? We're pretty sure that these are the right numbers, but you know, there's a little bit of room for error. And given the margin of error, and there's overlap, we don't know, you know, who's going to have a larger share of the vote. Now, of course, that's not the only data point, and this is in July, so there's going to be a lot more polls. And this poll was kind of an outlier in terms of the width, the spread, ranging from 15% down to this 2%. So again, we don't know what the truth is. It could be changing, right? I mean, some of these are for overlapping times, but it could be changing. And this is an example of random sampling you know, and the question of the methodology and how that works. So it's difficult to say. What Real Clear Politics does is they try to average things out to give you an average spread. That is a way of kind of putting the different results together. But, you know, we don't know what's going to happen. What I want you to understand is that polling is a way of trying to understand the world. It has a mathematical logic behind it. When we talk about top lines, we're kind of making it sound simpler than it is. And I want you to understand that there's nuance involved in all of that.